Okay, here's the video showing how to build what's known as the heated build platform. And the heated build platform is actually on the printer. This is the printer upside down, one of the original versions that's getting retrofitted with the new heated build platform. It's also getting a new RAMPS 1.4 controller on it, and so figured I'd show it to you since it's already on the table. Anyway, what we're going to do is we're going to take all these parts and we're going to build the heated build platform. And what that is the part of the printer that if you flip this over, you can see that it's the part that actually goes back and forth. What we're going to do, this is the back side of it. You can see around here we actually have like a strain relief wire tie that goes through it. Yeah, this one has an old piece of cardboard that we'd cut up before we actually got professionally cut pieces. And then you've got strain relief on the wires, both for the thermistor wire, which is this one tagged with a little yellow Kapton tape, and then the main power wires going here. If you don't actually have strain relief on these, eventually as you use them, you're going to actually rip them right off the board, and nothing good comes of that. Okay, let's go ahead and see what we have here. The reason we're starting with this as like the first major assembly is that in it, it is the second most complex assembly of the whole printer. The good news about it is that it gets rid of a lot of pieces quickly, and it gets rid of a lot of the small pieces. Most of the small washers, a lot of the screws, a lot of the fiddly little pieces that you don't want to lose and then have to go and hunt around to try and find them. And we're just going to get them out of the way. It makes it a whole lot easier. If you look at it, it doesn't look very fancy, but there's around 120 parts in this assembly, so it is important to actually get it done right. So what we're going to do, I'll try and describe some of the pieces that you're going to need for this assembly. You need your Kapton tape. It's not only for a heated build platform, it works really good for insulation of wires. In fact, that's one of the main uses for it. And then, especially for high heat things like your heat bed, Kapton tape works really good. And then you also will use this later to put it on your heated build plate. If you're going to print with ABS, works really, really good with that. You're going to get to your first 6 pieces that are printed pieces. These are your Y linear bushings for your slide as you go here, and they actually kind of hold their bushings for these little LM8UU bearings. You'll hear some people that say, you are LME 8UU bearings. All that is basically 2 of these bearings back to back, and it makes an extra long bearing. The truth is, it doesn't really matter. We kind of like it spread out. By spreading it out, it allows for less angular movement, and it makes for a little bit smoother print. So you'll need 4 of these. You will need, of course, 4 of the Y printed pieces. These were actually printed on a Vision 3D printer, so they're small little pieces, and they're fairly flexible. And so if you look, they've got holes on the bottom, and the big piece here, and then you'll need the other 2 pieces of your 6 printed pieces that you're going to need are small little belt clamps, and these are a piece that I actually redesigned. Originally they came in much longer, and so the problem with that is that as you put a lot of force on these, and I put a lot of force on them because I don't want my belts to actually slack off at all, then you can actually flex this. It will actually flex a little bit, and under high heat things, especially if you use PLA, it makes a big difference. Your belt clamps will actually flex enough to eliminate the belt, and cause slack in it, or it might actually just slip the belt totally out of it so that your gear for your Y-axis won't even grip. So there's your 6 printed parts that you need. We're going to use a bunch of these. I think there's 13 of these small little M3, one half is the how many threads per millimeter, because these are metric, by 25, and 25 millimeters is roughly 1 inch. So if you take your calipers, these are the longest small bolt that we will use. So you need some of these, 13 of them. You need 7 of these smaller ones. These are the next size smaller. They're also an M3, so they're the same diameter. They have the exact same diameter, same head. and they use the same Allen wrench in them, so that all of that's the same. The only difference is that these are M3.5 by 16 or 14. It doesn't really matter whether they're 16 millimeter or 14 millimeter. I've included, you know, one or the other in the kit depending on what they had in stock when I ordered the parts. You of course will need the nuts for those, and these little hex nuts are really, really small, and so this is one of the reasons that we're actually getting rid of these. It's very easy to lose these on your workbench or your table, you know, especially if you have carpeting, and it's practically impossible to see unless you use a bright flashlight to find them. So, and then you're going to need, of those, you're going to need 24 of these M3 nuts, you know, basically one for each one of the screws, and then for 4 of the screws, we're going to double them up. On the bottom of the belt clamps here, I double those up, and the reason is because this undergoes so much tension going back and forth where it's actually flying back and forth so quick. I want to make sure that those 4 bolts are really, really tightened down, and so I use 2 nuts back to back, and that's called a jam nut is the second one. And what a jam nut does is that you actually put the 2 nuts in tension, and by putting the 2 or in compression, and it actually puts the bolt itself in tension, and that holds them all together so that they don't slide or slip, and you end up getting a lot longer life expectancy before you actually have to do any sort of routine maintenance to improve your print quality. Then we're going to use, these are number 6 washers, and they're the SAE or American Standard, you know, or Imperial Standard, depending on how you like to talk about it. But these are an M6 or a number 6 washer, which is close to an M4 washer. Even though we're using M3 screws, I like number 6 washers for 2 reasons. One is that it will use the same, we can use the exact same washer for an M4 screw or for an M3 screw. And what's really important, you know, most important thing is that the head can't actually pop through the washer, and it can't. You can't even see it when you wiggle it, so that's really good. But I like it also because it provides a larger surface area to contact as you're actually tightening this down, and it's really kind of important for materials that, although they seem hard like wood, then as you really tighten these down, they somewhat get a little bit squishy. And so when they get a little bit squishy, then things like the heads, which are really small, of these socket head cap screws, can actually start to pull through almost like they're drilling through the material. So with that, I like a little bit larger washer. And the other reason is that some, you know, RepRap printers use a combination of M4 and M3 you know, screws, and when you get down to it, it's, you know, it's kind of hard to separate one versus the other, and you end up putting M4 washers on your M3 screws, and in the end of the kit, then you're left with an abundance of M3 washers, and you end up having to redo a bunch of your work. I don't like that. I like part simplification. So with part simplification, even though we could have went with the smaller washer, it makes it better for being able to keep track of things. It makes it also better to be able to purchase things in bulk. We explained that this is your thermistor wire that you're going to actually pull out of your wiring package. So you're going to get a package that has wires in here. We already used up the main power wire that comes in, the AC volt power wire that also had your gray you know, protective cover when we built the power supply. And so this one is a small thermistor wire hooked to a cable that actually has a plug on it, and it actually says therm on the back side of it. You can't hardly see that with this camera, but when you look at it, this little bead right here, it's a little glass bead on the top of what's called a thermistor, and these thermistor wires here are actually made usually out of a stainless steel or a steel, and then it's coated sometimes with copper or other, you know, conductive metal, and then we end up using crimping them on because there's no other really good way, you know, especially if it heats up a lot, to actually connect them. So what it is right now is it's got these 2 bare wires, and the 2 bare wires could touch each other. If they do, they short out, and then you'll get either an error if you're lucky on your controller, or if you use an older firmware, older software, you'll actually think that it needs to provide a lot more heat to you. So that's a problem. So what we're going to do is we're going to actually use some of our Kapton tape. Part of the reason for it is that we could actually just tape this onto our heat bed as is, and then hope that these two wires don't, kind of touch each other. But what we're going to do is run little Kapton tape around it, and then actually wrap around one of the wires, which is all you really need. And then we're going to actually coat the whole thing with Kapton tape and put it on the bottom side of this board. So anyway, so you need that, and that's the only wire that you actually need to pull out of your wiring pack right now. But you do need it out of your wiring pack. So if you get it out of the wiring pack, then you're good to go. Just kind of set it aside, put your wiring pack back with your rest of your hardware, and then you don't need to worry about it. This is the plastic pieces you need. So long as you pull the 6 pieces out of there, and we're starting off with small pieces, so you're going to have to probably root around a little bit in order to get them out of there. If you look, there's probably 6 or 7 pieces that are about this size. These clamps both have 2 little holes in them, so that's unique versus any of the other small pieces. So anyway, just make sure you get the right pieces. And then we need a belt, of course, because these are belt-driven axes. The y-axis is belt-driven. The x-axis is belt-driven. Well, with this, we need a belt. And so what I did is I actually purchased a belt that is large enough, so it's super long, that it is long enough that is one big huge loop. And so what we're going to do is we're going to end up cutting that, and then I'll show you how to cut it and not make a mistake when you're cutting it. It's very important. A lot of people like to cut them before they get them, or cut them before they actually install it. I don't like that method because it lends itself to cutting a belt too short, and then you're out a week or two waiting for another belt to arrive, and just kind of wastes everyone's time. Wire ties, you're going to need a lot of them, basically because just the little black wire ties. I've probably included 100 of them in the kit total. Some of them are in the tool kit, and some of them are actually just in the hardware pack. The wire ties mainly are so that you can go ahead and wire tie different wires together. Some of the stepper motor wires, they just come free floating. You don't really want that. You want to be able to kind of control where the wires go, and so a couple of wire ties create a lot of benefit for the amount of headaches that they're going to relieve you of. Once we go through, we're going to start assembling this. It's pretty easy. The good news is that you only need 4 tools right now. One is that you need a scraper or your razor blade. How you do that is you open it, and this is actually backwards, that way you don't cut yourself this way. When you flip it around, be real careful if you got little children around. This side is extremely sharp. Razors do 2 things very well. One of them's cutting, the other one's scraping. So what you want to do is make sure this kind of gets lined up there, and you'll kind of hear it click. There it goes. When it's in the right place, and then you just slide this back and it's locked in there, then it gives you a pretty good razor blade. So you need a razor blade, you need needle nose pliers with the diagonal wire cutters on there, and you need your adjustable wrench. You can either use the adjustable wrench on the small nuts, which works pretty good, or the needle nose pliers. I usually just use the needle nose pliers unless I'm really tightening it down, at the end. Then I'll use the adjustable wrench for it. And then last tool you'll need is the Allen wrench. And this Allen wrench is the middle size Allen wrench. It's a 2.5 millimeter Allen wrench, and the reason for it is because that's actually the size that goes up in these little heads. So when you turn it, it works really good. So what we're going to do is let's start assembling this and see how far we get. So first things first, I always like to get rid of the pieces that are sub-assemblies first, and that way when you actually go down to the original board, then they're already prepared. So what we're going to do is we're going to actually take out the LM8UU bearings out of the packages, and if you look in them, they're a little bit oily. That's okay. I just leave the oil on it. I don't even bother with it. And we're going to take our first plastic pieces, and we're going to just slide these in there. So to do that, I kind of spread it with my thumb a little bit and slide it so that they are flush. Okay. Next up, we're going to take the screws, and if you look, there's a hexagon side on one side and a round side on the other. The screw goes in the round side, and you might end up having to twist it if you have to, if it's a really tight fit on some of these things, and get it all the way through. And then the hexagon side, of course, is for the nut. It's called a nut trap, and it's a great thing about plastics is that you can print in any of the extra stuff, and it really requires no extra effort to have it print for it. So it's a great thing about 3D printing. Anyway, I'm not even going to tighten this up right now. I'm just going to kind of leave it loose, but the one thing I will do is try and push the nut into the nut trap. That way we don't lose it. We're going to actually maybe pull this out a little bit later when we actually put it on the linear rods. So for now, we're just going to leave them in there. So basically it turns 4 pieces into one subassembly. Let's do that 4 times. And we're going to go ahead, get another screw, make sure it goes in there. And like I said, some of these are a little tight. And once it gets almost in there, we can use our thumb to kind of spread this a little bit. And so we're going to take another LM8UU bearing, get it out of the package, and slide it in the end. Make sure it's flush, because that's kind of important. You don't want to shorten your axis by having this stick out a little bit. So in order to get the maximum y-axis, you need it flush in there. And then we put the other nut on there, and once it's in there pretty good, then we line it up with the nut trap, and it's good. So 2 sub-assemblies done. Let's do 2 more. Going to go through, like I said, these first ones go a little bit harder, and get another LM8UU bearing. Actually, let's get both of them out of the package and have a second one waiting there. Okay, slide it in place. And these bearings, if you look, the bearing holder is the exact same length as the bearing. So that's by design. So it's very, very nice design that way. I like these. These were made, I think they're a Jonas Cooling on Thingiverse design. I really like them a lot. So anyway, I go ahead and use the pieces that I like the best. It's a really great thing about RepRap panels is that if you find a design you like, just incorporate it with your own, and you end up getting the best of all worlds that way. Line up the nut in the nut trap and kind of push it in there, and we've got 3 done. Number 4, we'll put the bearing in first this time. Kind of slide it in there. Like I said, you can use your thumb to spread it if you have a little bit of hard time getting it in there. And so now, with this, as soon as we're done with this, we've turned 16 pieces into 4 pieces. So that's what we're looking for. Eventually, we're going to turn around 120 pieces. I think it's like 113 plus some pieces of kept on tape. We're going to turn those all into one sub-assembly, and one sub-assembly is a whole lot easier to play with. So here we go. Put this nut on that one, just like the others. You want to, I've put in some extra nuts just in case you actually lose one, and drop it. It's very easy to do. Who wants to stop everything to run to the hardware store? Or in America, if these are metric, you're going to actually have to buy them online somewhere. And so once those are all done, then you've got 4 sub-assemblies ready to wait for you. Okay, next up what we're going to do, let's get this out of the way. We don't need it quite yet. We're going to take the razor blade that's on here, and we're going to actually use that to slice this. And so this kind of belt is very, very tough, and so razor will cut it, but not a whole lot else will. So what we're going to do is I'm just going to put it on the table, and then I'm going to slice it, and that way it will actually slice pretty good. So watch your fingers, and you hear that's a pretty tough cut, even for a razor. Okay, so we've got one end open. We're not even going to bother cutting the rest of the of this yet. And in fact, in this whole subassembly, we're not going to bother cutting it. We're just going to leave it be until we actually mount it onto the y-axis. Then once it's looped all the way around the machine and we pull it tight, we'll leave maybe you know, a half inch, 12 millimeters, or a little bit longer, but we don't want to leave this too long and have it flop around. I've never actually had a belt cut. I've never had one actually give way. With bad belt clamps, I've had them actually pull out, but you don't really need a lot of excess. And then we're going to use that little bit of a tab on the end with needle nose pliers. Once we line it up, we're going to use the needle nose pliers, and we're going to actually clamp down on that. We're going to twist these, and what that will do is that will actually cinch up and tighten up our belt pretty good, and that way we can go from there. So let's put the belt kind of out of the way right now. What we're going to do, this is the heated bed itself. If you look, there's two sides of this heated bed. Both of them have a hot zone, do not touch. Well, with our design on this printer, we're using mirrored plates, so you're really never going to see that. We're going to take these off. They're just for packing. They're extra. We don't really need them. So this side is the side that will be down, whereas if you can see it, the side that goes up is actually got a bunch of little lines here, and that's actually what creates the resistance. Those thin little lines of copper with 12 volts going through it create the heat for the heat bed. We want that side up because what we want to do is have the heat bed, when it gets done, the mirrored plate will actually go onto this heat bed, and we want the hot side of the heat bed, which is the top side, which actually bows a little bit as it gets hot. We're going to have the mirrored plate on it, and that mirrored plate's going to stick on it pretty good. And in order to keep it on there, we're going to use these bulldog clips, and they'll actually clamp the mirrored plate. So anyway, for now, we're going to put that out of here. We're not even going to bother with the mirrored plate because we don't want to have to deal with the mirror or crashing into anything until we're ready to actually start printing, and so we're going to keep that off. So what we're going to do is we're going to take this plate and kind of put it off to the side also. We don't need it just yet. If you look in the, all of these four pieces here are actually in the heat bed pack. So these four here will come in a cardboard package, and you get two of these. And they're not just for packing. We're going to actually use one of these because that's actually our insulation. This insulation will actually be in between the bed, the heat bed itself. It'll ride on top of the heads of the screws, and then on top of this will go right underneath where you can't hardly see it, under here. So it's sandwiched in between the circuit board and the Y bed itself. So we're going to put this off to the side right now. Okay. What we do want is we want the main plywood panel. Funny thing is, wood works pretty good as an insulator, and it works really good, you know, in its resistance to heat at the temperatures that we're using. If you look, this heat bed actually has two sides to it. Well, one side looks like wood graining. It's actually printed on there, even though the thing's made out of wood. This was a cabinet grade plywood, and what they end up using it for is for counter displays and stuff in like stores. And so, anyway, it's printed on there. That gives you a wood grain finish. You won't see too much other than the edges, so you can choose whether you want that or you want the yellow side up. What I've done is there are a ton of holes in here. If you'll see this side and that side, Boothroyd Dewhurst would kind of like that because I made it for manufacturability. If they did it, they would have actually made it so I could actually flip it. I don't like being able to see the holes on the front of the printing machine, so I didn't actually put some here. But this is the back of the machine, and so the back of the machine here is with the Y motor, and it's also where you have all the wire ties, because you're actually going to take the wiring and use wire ties on here. So first things first, let's get all of our mechanical components on here. So we're going to take 4 of these, and if you look, there have 4 holes there. So you determine whether you want up or down. I kind of like having the wood side up, so we're going to actually flip this over, and we need to pick up some screws. Okay. The funny thing about this is that of the 2 bolts for each one of these, there's going to be 4 of them all told, and so there's going to be 8 total. Out of the 8 bolts that hold these on here, 1 is different, and the one that's different will be the down one that holds this hole right here. And the reason is because we use it on here. I don't know if you can see it very well, but it is where our flag is. So as this goes back, it actually will end up touching this limit switch here, and I don't know if you can hear it clicking, but that one being longer is actually what we use for the flag for the limit switch, and it works really, really well. It also allows you, if you look, by the time it hits that, this is within the last 6 millimeters, you know, quarter inch of hitting the rails here, and so that gives us the full drive all the way through. I shortened up the end stop holders here, and anyway, with that, then gives you a little bit more space to play with. So we're going to take this. Let's go ahead and we will go ahead and assemble all the ones that require M16 or M3 16 millimeter long screws. So what you're going to do when you flip this over, this is wood. Like I said before, one of the things that you use washers for is to keep it from pulling through. So we're going to actually put a washer on each one of the M16 screws. So let's go ahead and do that. We'll put a washer on the M16 screw and then go ahead and push them through the right holes. Remember, the one hole, since this is flipped upside down, the one hole that you want to have the M25 is this one here. So when you turn it over, that's this one right here. So let's go ahead and do that so we don't forget it. And these holes, I made them very tight. I did that on a reason, you know, for a reason. The reason being that we want to have it so that as it's a tight fit, that it's all very accurate. We machine these on a machining center. So with that, put the washer in here. And so long as you make sure that that goes in the right hole, should be pretty good. Once it goes in there, I mean, you can actually push it this way, or you can actually push it up against the table. And it will actually drive it through a little bit easier. And that way, make sure you have a table that you don't care about if it gets scuffed or that it's tough enough to. We're going to do the others. Put the washer there. Put your M16 screws. All the other holes get an M16 screw in there. So what we're going to do is we're just going to get them barely started, and then we're going to use our tabletop method of being able to press them in there. And this will actually use up all of the M16 screws, so once those are done, you don't really have to worry too much. All the rest of the screws on the assembly of this thing for the machine screws are the M3 25 millimeter. So 4 done. And on these, if you look at washers, they have 2 sides sort of to them. Because they are stamped, they're not actually machined, they have a side that has like a lip on it, and then they have a smooth kind of rounded side. On these, for wood, we don't really care which one goes up or down, but for the acrylic panels, you always want the rounded or smooth side to be touching the acrylic. You don't want the sharp side, just in case it has a little bit of a lip to it. It could actually, you know, slightly cut into the acrylic. It's not going to pull through or damage the acrylic in a way that's going to be mechanically significant, but what it would do is that everywhere you cut acrylic will actually start shining light through it. It works kind of like a light pipe, or, you know, a sheet of acrylic acts a lot like fiber optics, except instead of a fiber you have a plate, and with the plate, that's what allows like the vision on the side of the Vision 3D printer to glow. So here we go, we got 6 of them done, sort of. And then we just barely get them started. Okay. So when you're done with that part, you have 8 screws in 8 holes, and you got 8 washers. So what we're going to do, kind of use our little tabletop method here, and push them in a little bit until they poke through. And when you got them all seated, then they'll look like that. Okay, so now it kind of matters when you go to tighten these down which orientation now. Remember, one side has the nut trap and the other side has a screw. I always put the head of the socket head cap screw on the inside, and the reason is because it's easier to get in here from this side to tighten them up. You don't need to have anything on the back side because that socket little nut trap that's in there that acts like a natural socket, you don't have to have a wrench on the back side. So what I always do is I put the screw head of your socket head cap screw on the inside. So we're going to go ahead and do that. You just kind of push them on there. they'll be tight, but they actually fit really well. We're going to go ahead and put all 4 of these on there first. And then you'll put the nut on each one. So like I said, you want to make sure, I did that one backwards. You want to make sure that the nut is on the outside, the socket's on the inside. So kind of push that through there. And this one's always a little bit harder because it's got that longer thing. But anyway, stick with it and they'll pop on there. Screw head on the inside. And you want it far enough on there that the nut will actually be able to catch on it and then start threading onto the bolt. So here's the last one. And there's that. So now we need 8 nuts, which is good because that gets rid of them. And you need 8 nuts and you need your Allen wrench. So what we're going to do is I'm going to just kind of hold my thumb there with the nut while I twist it on the back side with the Allen wrench. And if you look, eventually it starts pulling the nut in. And the good news about these is that although it twists, it has a little bit of force to it. We're not even going to bother with the wrenches. We're going to actually use these needle nose pliers, which actually hold it pretty good. So let's see if you can see that. And we twist it, and it's just enough force that it holds it. Now we do that 7 more times and we got this assembly or sub-assembly done. And we don't actually need washers on the back side of here. The good news about the plastic is that it's actually pretty tough stuff. It doesn't really want to pull through. This one I didn't even need to bother with putting the needle nose pliers on it. It kind of grabbed good enough in there. So if you're lucky enough to get by with that on all 8 of them, go for it. Okay, so same thing. We get this one. These don't have to be super tight. I've never really had one come off. It's not like it's being pulled like the pulley back and forth, thousands of times a day. So they do need to be tight, but they don't need to have a wrench where you put the wrench on it. Okay, so now we have the long bolt here, and so we're going to do the same thing with it. It's a little bit more fiddly to get it on here. And just kind of hold it there, and if you have to, you have to wiggle around the nut a little bit, and eventually you find the place where it needs to go. Sometimes it's easier on nuts to actually back them off a half or full turn, and then you start it on there. Once it gets started, what we're going to do is we're just going to use our finger to quickly move it up the bolt, and then we tighten it up. And the thing about Allen wrenches is that they have 2 ways of doing it. One is the easy way, which is this way. The other way is using it where you want a little bit higher torque or higher force on it, then you can use it the long way. Normally I use it with the short part up there because then I can just twist it around and keep twisting it until it gets tight. So anyway, we're done with 4. Let's we're done with 4 of them. Let's go ahead and get the last 4 on here. And that way it turns 35 pieces into one sub-assembly. So when we're all said and done, we will have one full assembly, which is the printer. Now it's very important that you actually get these as tight as you want them before you put the rest of it together. Part of the reason for that is that we want to actually make it so that these are tight enough that we never have to retighten them, because it's to retighten them you're going to have to remove the heated build bed itself, and in order to do that then you got to cut all the wire ties that goes and holds the heated build on there, and it just requires a little bit more time to do it. So I'm going to quickly go through and get all these on here. If you lose a nut, it's not a big deal, remember, because I included extra ones in each of the packets. So when you lose one, it's a whole lot easier to just go ahead and pull one out of a pack than it is to try and waste time, trying to find it. Okay, so there we go. We got all 8 on there, and we've got all of our LM8UU bearings for the y-axis. You'll still have some for, 4 of them for the z-axis, and you'll still have 3 of them for the x-axis, but that ties all that up into a nice little component. So next up on here, we're going to go ahead and we're going to put our belt clamps that are on here. So once again, put a washer on your M25 bolt, and we're going to slide it through. Same orientation as the others, so they all go from the top. And we're going to do all 4 of those, and then we're going to use our little press on the table deal to speed it up a little bit. I'll put this down here. And sometimes some people find it easier to actually go ahead and put all the washers, on the bolts themselves. So let's go ahead and do it that way for the other 3. That way when you reach down, you don't actually have to drop the subassembly for anything. Here we go. Now these 4 go really close together. Part of the reason for the belt clamp is that by having the washers on there, then it actually helps the belt clamp. It allows you to put a whole lot more force to it, which is always very important. Belts you want to have tight. I mean, as tight as you can possibly get them, that's how tight you want them. So what I do is I always put as much tension as I can, but in order to do that, you got to be able to hold the belt. So that's the purpose of having washers and these screws on here. Okay, and we want to get them just in there far enough that as we press on it against the table, that it actually is going to go through. That way we don't spend all day working on that. Okay, so let's see. There we go. Okay. So now having all those through, you can get rid of a little bit of sawdust that's in there. Doesn't matter if it has a little chip or not. The plywood's not really that flimsy. We're going to put these belt clamps, because there's a smooth side and a rough side. The rough side actually has like 3 little grooves cut into it. That's really all it needs. Some places use belt clamps so that they're very much for having the belt clamp match up with the number of teeth that are on the belt. The truth is, we put these in such high tension, especially on these smaller ones. We kind of want fewer teeth in there, and that way we can move it back and forth easier. And we're going to clamp it down so tight that even if we had the smooth side down, that it's going to hold it. So we're going to put the belt clamp on the front side. We're going to leave a little bit of space in here, but we want to put both of our nuts on there. And we're not going to tighten that down right now. We're going to do that later on when we go and assemble the Y build platform here onto the rest of the machine. But we don't want to lose the nut, so we're going to put those on here right now. Tighten them up so that you're not going to lose them. But that way you know where they are when you're ready to use them. So if you look, this is what I was talking about, where we use 2 nuts back to back on a bolt, and it puts the bolt both in tension and compression, tension between itself, and that actually, the tension on the bolt that you put actually forces compression between the 2 nuts, and by tightening them both against each other, it creates enough friction that there's no way that these things are going to actually loosen off of themselves. Okay, so if you look, it's got a little bit of space in there. That little bit of space is so that when we finally want to run the belt through there, we're not wasting a lot of time with it. You could make it a little bit closer, but that's good enough for now. Okay, so now let's do the second belt clamp. And after we get the second belt clamp on here, if you want to, you can go ahead and you can put a washer on here. Personally, I kind of waver back and forth. Normally, I don't actually use washers on there, so you could put washers on there. We're not going to. And so on this side, we're actually only going to put 2 of them on first, 1 on each side. And then we're going to put our belt in there. And it starts to get a little bit weird when you're dealing with a kind of like having a tail on this. So let's find one end of the belt. And of the belt, we want the tooth side up. And we just barely want it in there. I mean, you could leave it so that it has 1 or 2, but you don't want to have, big floppy thing hanging out there. One is it wastes the belt that you might actually need on the y-axis or on the x-axis. we're just going to leave like one extra tooth out there. So worst comes to worst, what that's going to do is that's going to actually help it so that as this tightens down on here, we can tighten these by hand a little bit more. Then we want that also to kind of line up right smack in the middle of the top two holes here. So we're going to kind of, it's kind of weird holding it this way, and it might be better to actually tighten it up a little bit first by hand, and then we're going to go through, find the right socket heads on the back side, and tighten it up a little bit so that we can still move it. And to get it tightened on the belt, you don't really need any wrenches or anything, but we are going to use a wrench on this because we want a little bit more force. If you look, I pushed it through, and it's still got enough force that I can push it through, but it takes a little bit of force to actually be able to do that. So we're going to tighten this up as much as we can by hand, and then we're going to actually put the wrench on it and tighten it even more. So that's about as good as I can keep holding it on that one. And do it on this side. Okay, time for a wrench. So here we go. Third tool we're going to use is the wrench. If you see, it kind of starts to pull a little bit into the belt clamp. That's not a real big deal because the ABS, I'm putting way more force on it than I would on the wood. The wood would have already actually pulled through. Okay, so you adjust your adjustable wrench down and you tighten this up. And you don't want to tighten it so much that this starts pulling all the way through the clamp, but you do want it tight enough that it's going to hold the belt. So if you look, when you actually take apart one of the machines that I've put together, you'll see that instead of having a bunch of belt teeth anymore, I've clamped them down so hard and ran them so hard over the length of months or so that this is not going to be able to actually pull through. If you look, it's a little off there. I'm going to actually kind of loosen it up a little bit, and when you pull this in the middle part, you should see that it lines up on both sides, and that way you know that the belt is actually where it should be. So we're going to actually loosen that up a little bit. And readjust it just a hair. It's better to do it this way and to find out than it is to kind of go with it the first time. If you have to readjust things, it's always easier to do it before it gets on the machine. Okay, so let's adjust this just a little bit. If we have to, we can use the Allen wrench to push it on the other side. Okay, now we're going to kind of hold it, and once it's tight, that looks pretty good. So let's retighten it again. This time, once we retighten it, the nuts have actually kind of bit in a little bit. And I'm going to use the wrench anyway. And adjustable wrenches, I don't know if most people have seen them before and used them before, but if you've never used an adjustable wrench, the great thing about them is that you don't have to have a full toolbox full of every kind of metric and standard wrench available. You can adjust them with the little thumb screw. So if you turn the thumb screw one way, you make them bigger. You turn the thumb screw, which is this little thing here, the other way, you make it smaller. This is a really very handy tool for all sorts of different things. So we're going to use these not only for these small little screws, but when we adjust them all the way out, we're going to use them for the 1/2-inch screws that we use on our 5/16/18 rods, a little bit later. So we're also going to use it for our M6 screws that are used on some of the different components in here. I think I only use an M6 screw on 5 different components. One of them is actually a little bit harder than the others because we're using it for the extruder to be able to line up the extruder nozzle and to put it in tension and compression using it like a jam nut technique to be able to get it on there. So anyway, here's what we have. We have the little tail sticking out here. If you want to, you can actually take this whole tail because it kind of gets in your way after a while. Wrap the whole thing up, and let's burn up a wire tie. So it's easier to use a wire tie once in a while. If it gets everything out of your way, I mean, truth is, it might not bother you at all. Me, I tend to knock off things like any of the little washers and stuff, and so that kind of, after a while, it gets kind of annoying. So, okay, so here's what we have. We have all of our screws for the LM8UU Y-axis bearings, and we've got all the screws in there for the belts, and one of the belt clamps is actually tied on there. So that's what we got so far. So now, next up, we're going to actually start putting the heated build bed on here. But before we actually put the heated build bed on here, remember, if you look right on the bottom of here, we're going to have wire ties that go through here. Last thing you want to do is put that heated build bed on here and then have to try and snake a wire tie up through the hole and then back around through the hole. If it's not impossible, it's pretty close. So what we're going to do is we're going to take a wire tie, shove it through this hole, up one way, and then back down through. And we got one wire tie. So that's kind of what it looks like. You can shorten it up a little bit. The great thing about wire ties, these are made out of nylon. They can easily take any heat that the heat bed wants to put out. So it's not going to warp them. It's not going to break them. It's not going to melt them. So you don't need to worry about it. I'm going to do it again on this side. Snake it through that side and back through. Now if you had it, you know, where the wood side was down, you would do the same thing. You would just do it on the other side. So anyway, so now we've got both those wire ties in there. We're going to put a third wire tie in here now also. If it falls out, we can always put it back in. This one's not so critical, but we're going to put it in there. Great news about these holes is that they hold it pretty good. So we're just going to kind of leave it there. If you need to, you can always bend a wire tie. I always do this, you know, so that it's farther than where it's going to go once it gets cinched up. And that way, if you bend it a little bit, then it's not going to actually pop down the hole again. So anyway, so we got our 3 wire ties on there that we need for this part. And now it is time to actually start assembling the heated build bed with this. So what we're going to do is we're going to put this down on the table. And it kind of holds it like a little table, like there are little table, you know, legs under there.